The water electrolysis hypothesis postulates that electricity can be used to separate water into its constituent elements, hydrogen and oxygen. This separation is achieved by passing an electric current through the water using an electrolyzer containing two electrodes, anode and cathode, immersed in the water.
Our materials are water, salt, two coarse graphite pencils, a glass beaker, a 20-volt battery, and a pH meter.
Electrolysis is a process that separates the elements in a compound using electricity. A direct electric current is applied through two electrodes immersed in one solution, the anode connected to the positive pole and the cathode connected to the negative pole. Negative ions are directed toward of the anode, and positive ions toward the cathode, and electrons are transferred between the electrodes, giving rise to the new substance. This process involves an oxidation-reduction reaction driven by electrical energy. Michael Faraday was a scientist who studied and explained the phenomenon, formulating two important laws of electricity.
In here, we already connect the double ligature cable to the 20-volt battery and to the two coarse graphite pencils. The cable green is connected in the side of the negative pole and the cable white is connected to the side of the positive pole. Then we put the salt in the water. And we need to be sure that the salt is dissolved correctly in the water. Now it's time to put the two coarse graphite pencils to the water and see the reactions. And then we put some drops of indicator solution to the water. On the side of here we have a pinkish color, while on this side of here not, which means that on this side we have a alkaline solution that we are forming sodium hydroxide, while on this side we do not have this sodium hydroxide. The electrode that goes to the positive pole of the battery is called the anode, and the one that goes to the negative pole is called the cathode. The positive hydrogen ion will therefore go to the cathode, and therefore hydrogen will be released from the negative pole or cathode. On the other hand, chloride will be released from the positive pole or anode, since the negative chloride ion is attracted to the positive pole or anode.
These results indicate that water electrolysis is more efficient, with yields exceeding 96%. The yield is slightly lower. The proportion gases also varies depending on the electrolyte used. It is important to know that the efficiency of electrolysis depends on several factors, including electrolyte concentration, applied current, and temperature. These results are consistent with previous studies that have shown that electrolysis in acidic or basic solutions is more efficient than in saline solutions.
Water electrolysis results in the separation of water into hydrogen and oxygen through the application of an electric current. The process occurs in an electrolyzer where the water decomposes, producing hydrogen at the cathode and oxygen at the anode. The ratio of gases produced 2.1 by volume, respectively. We learned that the water electrolysis is a chemical process in which water is decomposed into oxygen and hydrogen using an electric current. This process requires an electrolyte to conduct electricity and is performed with electrons connected to an energy source. It is an important method to obtain hydrogen as a source of clean energy, and allows us to better understand redox reactions and the transformation of electrical energy into chemistry.